Good day, guys. Hope you're doing well. This is your next pre-calc class from, of course, your favorite teacher, which is me. So stop the madness, stop denying it to yourselves, and just liberate yourselves. Just say, Marcus is my favorite. But all joking aside, guys, here we go with your next class. This is actually, the examples that we're going to be seeing in the next couple of classes are from pages 212 to 214 from your textbook. This example specifically is on page 213. This is the example we're going to do today, and then in our next video, we will probably either be finishing the section or close to it. So as always, I'm going to explain the problem. I'm going to leave work assigned. You are going to do it, but you're not going to email it yet. I already sent out the instructions on how we're going to be working with the assignment. I posted it on the LMS in College One, and I also posted it through other forums in which you guys were able to see it. With that in mind, ladies and gentlemen, let's go to page 213. Let's do this. All right, so we are actually going to be talking today about finding the composite of functions or compositions of functions. Now, so far in our last video, we saw an example in which we combine functions by adding, subtracting, multiplying, dividing. We actually have an extra operation when we're working with functions, and that extra operation is the composition of functions, which is literally just taking one function and plugging it to the other one. Okay, so that's pretty much what we're going to be doing in this example. This is explained usually by the formula FOG, or f of g. Now, this does not indicate multiplication. It actually just indicates that you're plugging one function into the other. If it were a closed point, then it would be multiplication. So just explaining that, because a lot of people get really confused and assume it's automatically a multiplication. We're literally plugging one function into the other, and I can also write it the opposite, like we see in this example, f of g and g of f. In both cases, it's the same. It's literally plugging one function into the other. So let's get down to it. This is on page 213, and what they're asking us to do is to find f of g, find g of f, and then evaluate those functions, in this case for 5 and for 7 respectively. But how do we get started? How do we do it? By the way, a lot of people ask me about this eraser. It's a magnet, guys. It's a magnetic eraser, so it's not magically standing there. But that being said, let's go back to what I'm supposed to be doing. Anyway, right here, you're supposed to evaluate the functions. And we have f of x, which equals x squared, and we have g of x, which equals x minus 3. So when we look at the first example and they're telling me find f of g, what they want us to do is plug one function into the other. Let's reestablish. So we know that f of x equals x squared, and we know that g of x is x minus 3. So f of g literally means that we're going to take this x minus 3 and we're going to plug it in here. And we're going to get a composite function. And that's going to be f of x minus 3, which is what I instead of writing x, I wrote x minus 3 squared. And that's it. That's it. That's all I have to do. I don't need to do anything else in this case because it's a really simple function and I don't have any radical signs, or I don't have any fractions, or I don't have any numbers on the outside. This is it. That's it. That's all I'm going to do for that problem. And now we're actually going to move on to the second problem, which is g of f. And once again, I do this step. You don't necessarily have to do it, but I'm doing it just so that you know what we're doing. And again, f of x is just x squared, g of x is actually x minus 3. So what we're going to do is now the opposite. We're actually going to plug this function right here into the other one. So how does that look like? Well, g of, now instead of writing x minus 3, I'm actually going to change the x, and I'm going to plug in x squared. So it's just going to be x squared minus 3. So g of f equals x squared minus 3. And that's it. That's it. That's as simple as that. That's all I did for the exercise. I don't really need to do anything else. For example, 3a. I am going to go into 3b, and it's really simple because they're telling me, okay, so now I want you to find f of g, but x is going to be 5. And I want you to find g of f, but now x is going to be 7. So what we're going to do is we're going to take our answers, the answers that we got here, and we're going to plug in a 5. So f of g of 5 equals 5 minus 3 squared. And what we're going to do is we're going to use our order of operations. Obviously, parentheses goes first. So 5 minus 3 equals 2. And that's going to be 2 squared, and 2 squared equals 4. So f of g for 5 equals 4. And we're going to do the same thing now for g of f, but now we're going to say 7. So g of f, or of 7, is actually saying 7 squared minus 3. And again, we use order of operations. Our exponents go first, and that would be 49 minus 3, which equals 46. And that's it. That's how hard that example is, guys. That's it. It's done. We're done with it. We're done. No more. Okay? So what are you going to do next? Well, you're going to go to page 216, and you're going to answer problem 27, and you're going to go to page 217 and answer problem 49, excuse me, not 44, 49. And that's it, guys. That is it. This is your favorite teacher. Stop the madness, ladies and gentlemen. Stop denying it, because you're only hurting yourself. You know I'm your favorite. So I will see you soon. Stay safe. And you know you're expecting me to say it, but I'm not going to say it, at least not yet. So have a great day, guys. Bye.